Welcome, welcome. Welcome to our free GMAT prep hour on June 1st. We are moving into a brand new month. I'm excited. May seemed like yet another crazy month here in 2020, so I'm excited that we're finally in June. My name is Whitney or Whit. You can call me either. I have no preference, one or the other. I am a GMAT and a GRE instructor at Manhattan Prep. I've been with the company since 2010. I've been teaching GMAT and GRE for many years longer than that. But this is my full-time job. I work on the curriculum, I teach, I tutor, all of the fun stuff. I get to work with students a bunch. And I love these prep hours because they give us a chance to step outside of the sort of formal curriculum and talk about some like cool tips, cool tricks, and ways of approaching problems. So if you aren't attending our GMAT prep hours, you should. And you should always check out the like trove of prep hours that are online on our YouTube channel. So we got lots there covering all kinds of fun information, quant, verbal, and a little bit of both. So the game tonight, the game this evening is going to be to discuss the first 30 seconds of quant problems. What happens during those first 30 seconds? So do me a favor, I want you to type in the chat window. You can send it to panelists or panelists and attendees, but I want to know, what do you do when a question hits the screen? Right? What do you do when a problem hits the screen? So like, put yourself in the mindset of test A and a problem pops up. Ooh. Haha. We've got some folks that are part of our crew already, it would seem. I've got things like read the question, right? Check to see what it's asking. Is it something I need to solve? Am I going to read the question? Maybe I'll look at the answer choices. I'll start taking notes. I can ID what kind of question it is. Oh, I see that a lot. Problem solving or data sufficiency, very cool. There's a lot of this like glancing, right? Taking a quick scan of things like the answer choices or let your eyeballs move around the screen. Start to break it down into its facts. Decide, am I going to solve it or am I going to bail? So let me ask you guys, right? In order to be an expert, how long do you think it should take you, right? How long to know what to do to solve the problem? How long do you think? How long do you think it takes an expert to know exactly what to do to solve a problem? Yeah, so here's what I'm seeing. I'm seeing a lot of people that are like, I don't know, 10, 15, 20 seconds, 30 seconds, 20, 30 seconds. Okay, so here's what I'll tell you. A couple of you guys had said it. I have no expectation of having any idea what to do on a problem until I've been on that problem for probably close to a minute. And I have some time. I have some decent time to just engage with a problem. Right? So let's start with this understanding that I would like to have an idea of what to do within about a minute. Then, since on the GMAT, we want to spend about 2 minutes per question. Again, this is assuming standard time. If I can know what to do in about a minute, then I have about a minute to try and actually do that thing, to solve it. Now, remember, an average 2 minutes means that sometimes we'll be faster. Sometimes we will know what to do within 30 seconds. Sometimes we might be a little slower. We may not know what to do until more like a minute and a half. And then that might be okay. Right? That might be okay. It just depends on the balance of our time. Are we a little bit ahead? Are we behind? Like, where are we during the test? But the biggest thing that I get from my students all the time is that they think that they should know what to do almost right away. That an expert looks at a problem and instantly knows what to do. And here's the thing is, we're not psychics. I wish I was a psychic. If I were a psychic, this test would have gotten really, really easy, right? So here's what I want to start with. I want to start with this idea that you aren't supposed to know what in the world to do in the first 15, 20, 30 seconds. Right? I don't assume that. I wouldn't expect you to. You can't read everything and process it instantly. You're probably not a psychic. If you were, you wouldn't be sitting here with me, right? And so I want to give you permission to slow down the first part of the test. Right? Slow down the first part of each question. So to that end, what do you do when a question hits the screen? The very first thing that you should do when the question hits the screen is close your eyes and take a deep breath. Right? Every new question is a new question. So we want to give it an opportunity to start fresh. Okay, so first thing we're going to do, we'll take a deep breath. Second thing we're going to do is what a lot of you guys said, which is to look and see what kind of question it is that we're dealing with, right? What kind of question it is that we're dealing with. So we're going to ask the question, is it problem solving or data sufficiency? Pretty easy, right? Problem solving or data sufficiency. Now let me ask you guys another question. Or let me pose a true-false statement to you. True or false? The GMAT quant section is a math test. True or false? The GMAT math section is a math test. Beautiful, guys. I'm getting a whole bunch of false. You guys are exactly right. It is not a math test. It is a quantitative reasoning test. Math test. When you took a math test, typically you didn't have answer choices. You had to do a bunch of work. You had to submit your answer, and your teacher or professor cared about the work. They cared how you got to the answer for the question, right? That mattered to them. In fact, you probably got partial credit for being able to show your work. Yeah, to find math test, right? So a math test is this idea that I need you to know a bunch of mathematical content, and I'm going to evaluate you on your ability to do that math. It's not that the formal, right? Like that. It's not that we're dealing with math concepts, but math means I need to make sure that you can do the formal math, and that's not the GMAT. The GMAT is not open-ended. The answer is there, right? For problem solving, our good old-fashioned multiple choice, the answer choices are there. For data sufficiency, we're not necessarily finding an answer to a question. We're trying to figure out if we could find an answer to a question. And so we're working with an open book test here, guys, right? We're working with answer choices sitting right in front of us. And so showing our work isn't part of the game. The test itself, as it scores you, it does not care how you got to answer choice C. It cares that you picked answer choice C. And if answer choice C is the right answer, you get the credit for it. If answer choice C is not the right answer, then you get it wrong. Right? So the GMAT cares not how you solved the problem. Now here's the thing. I have never once, ever had to talk a student into doing math and algebra. Never. Never. Not once. Not a single time have I ever said, like, okay, you know what? You're going to have to start doing the algebra. I'm sorry. You're just going to have to do math. Because every student comes to me assuming that they're going to do math. What I have to do is I have to try and like break people's death grip on math, because everybody in this room told me that false, right? The GMAT is not a math test, but I promise you right now, you're going to treat it like it is, right? People that study for this test treat the GMAT like a math test. Like, how much algebra can I do and how much algebra can I crank out in 2 minutes? And that's not useful to anybody, right? And that's not going to maximize your score. So what I want you to do is you're going to take a deep breath, because I want you to clear your mind when a question hits the screen. Right? We want to start from scratch. Big open place. The second thing you're going to do is going to be the easiest piece of all of it, is flat out just identify what kind of question it is. So you're just going to sort of say that to yourself. And the reason why is that I have kind of a checklist of things that I do at the start of a question that have nothing to do with reading the question or trying to figure out how to solve it. And these things take a little while. But I consider it this idea of information gathering. It's my opportunity to collect any of the clues and hints that the test writers are providing. I'm just going to let them sort of filter in. I want to get familiarity with the context of the problem that I'm working on. Once I have that, I can then start to jump into actually solving the problem. Now, here's the thing. Right? Here's the thing. Once I start to solve, once I actually start to get pen to paper and I'm working, I want to make sure that I've chosen a method that is intuitive for me, that's the laziest possible method I could have come up with, right? Like nice and intuitive, nice and lazy. Yeah. I want to be able to make sure that I'm not building on any false or clumsy assumptions. So when students jump straight into a question, what I normally find is that they pick really inefficient ways of solving. They pick long ways of solving, right? And they often make faulty assumptions. They read too quickly over words. They don't take in all of the information. And so the more quickly we move at the beginning of a question, honestly, it tends to be detrimental to your performance. So I'm going to invite you to my checklist. I'm going to invite you into my checklist so that we can start to think, what is it that I'm going to do during the first 30 seconds of the question? Okay, so a little bit about the quant process. If you studied with us before, we talk about quant problems all involving this process of understand, plan, and then solve, this UPS process. And I like this illustration that I'm about to give you because understand takes up the most space for a good reason. Then planning takes up the next most space. And then actually solving is sort of that blurb at the bottom. This is very indicative of how much time on a problem you should be spending in these stages, right? So when I say understand, I mean things like what type of question are they asking for, right? Like what specifically do they want? What have they given me, right? What information are they providing? What can I start to get on my paper, picture, or table? Once I've kind of got this big picture understanding, I move into a place where I'm able to start to plan. So have I seen problems like this before? What are some of those strategies, right? Is there a formula, a picture, a table, something along those lines that might be helpful? And then finally, I'm going to solve. So what I'm going to give you today, this first 30 seconds, right, like this primer on a problem, is going to help set you up so that you can answer the U and the P, the understand and the plan, with a lot more ease. So stick with me. It might feel a little clunky at first. It might feel a little clunky at first, but I just want to make sure that we're comfortable. So for those of you that have not seen the GMAT all that much before, I did want to highlight for you the two different question types that you'll see on test day. So the first is problem solving. It's a good old-fashioned multiple choice question. It'll always have 5 answer choices. They don't have to be numeric. There can be words there. There can be expressions there. But you'll have 5 answer choices. You'll have a problem at the top. You're going to solve that problem, just like you would a math question from your regular math class. You're going to get an answer and hope that it matches one of those in the answer choices, right? Like that's the theory behind problem solving. Now, the theory behind data sufficiency is a little different, a little bit different. So the theory behind data sufficiency is that you're asked a question up front, right? In this case, we want to know what's the value of X. You may be given some information, right? In this case, you were. If 2x plus y is equal to 7, what's the value for X? Now, there's all kinds of techniques in terms of actually solving data sufficiency problems, right? Things that we cover in depth in other prep hours, also in our books and our classes. But if I want to know the value of X, I'm going to then use my 2 statements to see if I can answer that question. 2 statements to answer the question. The answer choices, notice, are not numbers. It's not actual values for X in my answer choices. The answer choices are asking whether I could get to an answer. Like, were you able to find a value? And if so, how did you get there? Was it that you used only the first statement and the second statement wasn't able to help you? Were you using only the second statement, but the first statement didn't help? Did you have to put them together in order to get them to work? Was it that you actually could have used either? Statement 1 gave you an answer and statement 2 gave you an answer. Or was it that, you know what, I couldn't get an answer at all? 1 and 2 even together gave me nothing. Right? So data sufficiency is a question about your process. It means that we do often solve problems. We do try to figure out the answer to these problems, but we want to learn how to like cut ourselves off early. I don't necessarily need a value for X as long as I know that I can solve for X. Right? So in this example, we're not going to do the whole problem, but in this example, if I know that 2x plus y is equal to 7, and I know that y is equal to 3, I could plug that into this equation and solve it for X, which would make statement 1 sufficient. If I know statement 2, which is this equation with x and y in it, and I have a given equation with x and y in it, I can try to use substitution or elimination, any of our techniques for solving a system of equations, and I can get, in this case, a unique value for x and for y, meaning that I can get a value for x. If I can recognize that, then I can call this statement sufficient as well, meaning that all by itself, it can get me an answer, and I would choose answer choice D. Right. So just a little kind of quickie primer to data sufficiency. I'm going to pick D because I can get to an answer from both. Okay, but now what we're going to do is we're going to take a step back. We'll start with problem solving before we do some mixed drills. But we're going to start with problem solving and talk about what these first 30 seconds will look like. Okay. In the age question, oh, I had a great question in the background. For that earlier age question, that would be a great one for doing something like that. Yep, for working backwards, solving backwards from the answer choice. Sharp, very, very sharp. Okay, so with problem solving problems, the thing I want you to think about first and foremost, right? So we've taken a breath and we've decided that the question's a problem solving problem. The first thing I want you to do is take a quick scan of the answer choices. Okay, so before I tell you anything, here are a pair of problem solving problems. I want you to just focus on the answer choices. Just focus on the answer choices. And I just want to know what you notice. What do you notice about those answer choices? Feel free to type them to me. And honestly, there's no wrong answer. We'll see that some things that we notice are more useful than others, but there's no wrong answers here. Big numbers. Some of them are pretty numbers, some of them are not nice numbers, some of them are close together, some of them have dollar signs, some of them are fractions. So I love what I'm seeing. I'm seeing a lot of commentary on the type of number, right? Whether the number is an integer, whether it's a fraction. Is it big? Are they small? Are they spread out or are they close together? Right. And if the numbers are actually numeric and there aren't like symbols or being able to read them isn't obvious, if they're numeric, they will ascend or descend. So they will be put in order. Okay, so here are some of the things, right? Here's my little, and fear not, I'll give you like a summary of all this at the end, but it could be useful to like grab a little screenshot of this or jot down a couple of these. But in a problem solving problem, the first thing I want to do before I've ever even looked at this, the question itself, is I'm scanning the answer choices. And I'm typically looking for these 4 things, like what type of information is in the answer choices? What are some of the qualities of those numbers? Do I see any symbols? And then I want to know something about how spread out they are. So when I say what type, are they integers? Are they fractions? Are they percents? Are they decimals? Do they have variables? Do they have expressions? Is it words? Like what type of thing would be in those answer choices? I'm also going to ask things like, okay, are they small numbers, big numbers, ugly numbers, pretty clean numbers? Are some of those numbers paired up? We'll see what that means in a minute. Are they even, or some positive and some negative? Right? The quality of the number. I want to take note of any symbols, percent symbols, degree symbols, dollar signs, roots, pi, weird notation that I'm not familiar with. And then I want to ask this question that a lot of you guys mentioned, which is like, how spread out are they? Are they really close together? Are they very spread out? And then another piece, let's layer on this, is are there any natural breaks? Like, oh, some of these answers are less than blank and some are greater. And that's an easy number to think about. Like half of the numbers, 3 of them are negative and 2 of them are positive. That's a natural break at 0. Okay, so the first thing we're doing with problem solving is we're scanning the answer choices and we're looking for type, quality, symbol, and spread. Yeah. So let's go through it then. We've already said these things about these 2. In the first of the 2, we've got integers. They're big. They're relatively spread out except for C and D. They're kind of clean looking, right? They have dollar signs in front of them. Yeah. Beautiful, right? Like all of these are things that I'd want to notice. There aren't really any natural breaks here, and I'm not seeing a lot that's like paired up, but there are some clean ones, like 36, 40, and 45 are nice and clean relative to the other two. For the bottom one, these are all fractions. They're all relatively small, but there is a natural break right between a quarter and 2/3 that's around a half, right? So if I could tell something's more or less likely than a half, right? Like I could get to an answer. 1/36 is awfully close to 0, right? So it's a very small, small number. And so having these natural divisions can be really useful, right? Or at least noticing them. All right, let's try it with another pair. Take them one at a time, and I want you to start to think. And I put them both on the screen so you can like literally compare them and see like, oh, these are what different answer choices look like. And you can start typing into the chat window as you notice what you notice. Right, and you're looking for type. What kind of numbers are they? You're looking for quality, right? Are they ugly? Are they paired? Are they, you know, what's the story? Are there any symbols? What's the spread look like? Fun aside piece of content, 0 is an even number. It's just a weird number, but 0 is even. So the first one, we've got integers, wildly spread out. Wildly spread out. They're all multiples of 10. They're very, very pretty. No symbols for these. Maybe a natural break, but more I'm seeing things like 50, 100, 200, just like nice, big, easy, clean numbers. For the second one, they're words. Right? We got words for the second one. And they are, in fact, days of the week. And that's about all I can do with those. They're days of the week. Okay? We'll try another set. What do you think about these? Yeah, nice. So we've got fractions and variables in the first one. Right, so we've got that type is going to be a fraction, but it also includes variables. Quality is that they're all over the place. We have some that are like 3/7 versus 11. There aren't any symbols here. And it's hard to tell whether they're spread out because we don't really know what S equals, but there are reciprocals like 3/7 and 7/3. We've got all these like 3/7 and 11s running around, right? 3/7 and 11s running around. The second one, oh yeah, we've got that break over 1. So 3/7 is smaller than 1, 7/3 and 11/3 bigger than 1. We could also estimate those. Like 7/3 is about 2, 11/3 is about 4, you know, then a 7, then an 11. And the second one, yeah, these guys are super spread out. They're very big numbers. They're not particularly pretty, but we could make them work. 2700's nice, 8400's nice. And another thing to consider is that when we don't have an obvious natural break, but we want to do something like maybe estimate with our answer choices, I could put my own fake answers in. Like, hey, if I know if it's bigger or smaller than 1,000, do I know if it's bigger or smaller than 5,000? Okay. You could, if you're trying to estimate, look for, with numbers this spread out, spacing between them. Totally something you can do. Okay. What about these two? What do you see? I've got symbols and percents. First one's got percents, second one's got pi. If I see pi, I already know that I'm dealing with circles. Right? That's the only time we ever use pi is with a circle. So I know I'm dealing with circles. I definitely have some serious spacing in the first one. Notice that I've got this like 3 of them are under 50%, 2 of them are over 50%. They are paired, nicely done. 40 and 60 are 100, 16 and 2/3, 83 and 1/3 are also 100. That kind of puts 20 as like our lame duck. If I'm going to be guessing, I probably won't guess the odd man out. I'll probably guess one of the pairs. Down here, look at my nice easy multiples. They go up by 4 to 6, or like double in a lot of these cases. And so nice clean numbers if I want to use them. Right, so you guys are getting the hang of it. We'll try, I don't know, let's look at a couple more just to sort of get ourselves into the groove before we look at the next thing we're going to notice. What do you notice about these? Yeah, Roman numerals. Roman numerals. So the one on the top is a Roman numeral problem. You'll be given 3 statements to evaluate, Roman numerals 1, 2, and 3. And then your answer choices are going to be which of those Roman numerals fit whatever the question's asking for. The ones on the bottom, nicely spread out. They're integers. They're ugly. They're not very pretty. 104, 208, 228. Maybe you see their pairs. Cool. No, okay, so great question. Roman numeral problems do not always have the same answer choices. Right? They can always be different combinations. So sometimes you could have 1 only, 2 only, 3 only, 1, 2, 1 and 2 only, 1, 2, and 3. Right? So they can be different. It just depends on how the question's written. Great question. Right, so we've got integers. They're kind of messy, but they're pretty spread out. Let's see if we can do these. I just want you to now take note. I'm going to move through them pretty quickly. I want you to spend about 4 seconds, 3 seconds on each one and notice how much you notice. Notice how much you notice. I've got words spelled out. I've got fractions that split across 0. They match, negative a third, positive a third, negative 1, positive 1. In this pairing, I've got variable expressions with squared things. In the bottom one, I have integers in order, 2, 3, 4, 5, 6. They're small. That's kind of nice. I like small numbers. I'm going to play with them. Those are nice. Okay. What about here? I've got very spread out numbers. Right? 2.5 up to 20. Very spread out, kind of moving up by like doubling or up by 5s. In the bottom one, I have percents, and they are radically different, with the exception of 19,900 and 20,000. But notice 20,000 has a match at 200, 19,900 has a match at 1,990. Right? So all sorts of things just jumping out. Does it mean I know how to solve? No, it doesn't mean I know how to solve, but it helps me see my answer choices in my first one. I have matches, negative 256, positive 256, negative 116, positive 116. Probably not going to pick negative 64 if I'm just guessing. I've got them increasing by 5s, 15, 20, 25, 30, 35 on the second one. So they're a little spread out, but not terribly so. But they are really pretty if I wanted to use them. Very similar to the first question we saw. Cool. So step 1, problem solving. We're going to scan the answer choices. You might be sitting there saying to yourself, like, well, what use was that? Here's the thing is that you can already start to see that when things are really, really, really spread out, I immediately have a tool that could work. Estimation. When answer choices are beautiful and simple and clean, small little integers are like multiples of 10. If I need to use my answer choices, then those are the kind of questions I'm looking for. Right? I want to be able to utilize those to plug in. Symbols can tell me what kind of problem I'm working on. If I see things like dollar signs, I know it's a story. If I see percent symbols, I'm already thinking a little bit about solving with percent. If I've got square root of 2 and square root of 3, I'm probably dealing with some geometry and triangles. If I've got pi, I'm definitely dealing with circles. If I've got degrees, I'm dealing with triangles or circles or some other geometry like geometric shape. If I've got variables, side note, variables are a really good hint for who's studied with us before. What are variables in your answer choices a hint for? What might they hint? Yeah, so plug in numbers. Plug in, pick your own numbers, make up stuff. We call this like smart numbers. We call this a little bit like testing cases. It's basically like plug it in and prove it. Plug it in and prove it. So I'm cheating. I'm looking at the answer because I want to see where I'm headed. Okay, so the next 2 pieces, we're going to layer on top. We're going to go back and look at those same problems. So we've got our answer choices. The next 2 pieces are more about content. And again, I'm not reading yet. Not like really. I'm not like reading to fully understand the problem. I'm sort of scanning and just noticing what I notice. So the first of these is that I want to note whether the question is what I would call wordy, mathy, or geometry. So a wordy problem is one that looks like a story, right? And you could think about it as like story maybe instead of wordy, but like story, math, or geo. So like a story problem is going to have nouns in it. It'll have shoes and people and dollar signs and miles and that sort of thing. A math problem is going to be very formal math. There may be words, but it's going to sound very much like the integer this, and if this is even, and the positive this, and this is divisible by that thing, and the remainder. It's going to be very math language. And then geometry will be a picture or some sort of, they'll reference something that's geometric. The second piece we're going to look for, so we're going to look for these at the same time. I'm looking for any content clues. So I'm not reading yet. I'm not trying to actually read the story to understand it. I'm looking to see if any content clues jump off the page at me. And some we've already seen. So if I see a geometry picture, I'm going to immediately be thinking of whatever that shape is. Circles, triangles, coordinate geometry. If I see percents or fractions, I'm already thinking that we're dealing with some sort of proportions. If I see dollar signs, I know it's a real story. If I see words like rate or driving, or traveling at some speed, right? I know that I'm in like a distance, rate, time problem. If I see the word probability, the word median, right? Just what words are coming off the page at me? What words are coming off the page at me? What images are hinting for things? And then from there, we'll start to combine that information to allow any like strategies to start to come forward. Right? So the culmination of all of these things is where we begin to let the planning start. Given all these things, like, does estimation seem reasonable? Making something real would be like drawing out a picture, like sketching it out, or just thinking through the logic of a story problem, which is in essence kind of an estimation. I might be picking and plugging in numbers. Qualities like smart numbers, where you pick a number and plug it into the problem so you don't have to deal with a variable. Or testing cases where you plug in multiple values, or when you work backwards from the answer choices and plug those into the problem. And then there might be content-specific strategies as you just note these terms. Right? If I know that I'm in a problem that's talking about distances and speeds, I'm probably going to draw a picture. Right? As we start to work on probability, I know how I'm going to organize that. If I'm thinking about, if I notice that a question is testing what they call overlapping sets, I'm going to build a table. Right? If I have a problem that feels like proportions, I'm going to want to try and make it a ratio because that makes my life easier. And I'll grab that one at the end because that's a good question. I'll grab that one again. So what I want to do is I want to go through the same questions. We're going to go through kind of rapid fire, the ones we just did. And we're going to evaluate, is the question wordy, mathy, geo? What are the content clues that might jump out? And then we're just kind of thinking about what strategies would apply based on all the things that we've seen up to this point. Okay. So we're just practicing, throwing it out there for these first two. Story, math, or geo. Story, math, or geo. They're both stories. Ken's salary, word probability. Are there any terms or words? Well, for me, the word probability jumps off the screen. I see percents in the first one. Ken's salary is 20% higher. It would be this, right? I see that. I've still got my clean answer choices. So might be just easier to use my answer choices here, if possible. Okay. Story, math, or geo. The first one, story or math or geo. Definitely math. And it's all percents. So I'm going to need to know something about percents. The second one, story, math, or geo. Definitely a story. We've got a person depositing and then a withdrawing. This just seems like a relationship and we're looking for a day. So this is going to be a little bit more logic based than maybe doing algebra. I haven't read it. I have no idea what Jason is doing on Monday, Tuesday, or whatever day, but I'm already getting a sense of what the question is expecting from me, right? For the first of the two, story, math, or geo. Story. I'm just looking for stuff that jumps off the page at me. I see marbles. I love what Stacy sees ratios, right? Like 3 times as many as this, 7 times as many as that. If they have da-da-da-da-da, oh, it's like a ratios thing. I've also got that variable in the answer choice, which says to me, if I need to, I can plug in numbers. For the second one, there's fractions in the problem that are ugly. 4/9, 8/17, those are terrible. I've got some total number. I'm taking weird percents of weird numbers. What might we want to do, given our answer choices, if it looks like I've got weird fractions and weird numbers? Heck yeah, estimate. Heck yeah. 4/9 and 8/17 are both like a half. Now, I don't know what I'm supposed to do with them yet, but I'm already getting this idea in my mind. Story, math, or geo for the first one. Story, I know the answer choices have percents, and I see this one piece where it's like sold 3 times as many jeans and percent of their profit. So it sounds like I could do some sort of proportionality here. And it is, it's percents. Heck, even if I could decide if the answer was under 50 or greater than 50, that gets me part of the way. The second one is geo. The pie gave it to me alone, but my eyeball sees like sector of a circle. If I don't know anything about the sector of a circle, this is probably not a great question to work on. Roman numeral. Any words jump out at you? Yeah, prime number. Prime number. I also want to notice this, like, which of the one cannot be true? What can't be true? I want to see things like must be true, can't be true. What's a great word in the second one? And yeah, these are both mathy sorts of problems. Yes, approximate. Like, I'm going to try and estimate whenever I can. You better darn believe if they tell me to approximate, I'm going to be all over that. Okay? I've got numbers written as words. And all the words are like integer, multiple, prime. Like, I know I'm in a number properties problem. I know I'm in number properties problem. So I got to know something about number properties. What about the second one? It's mathy. I didn't think those answer choices are all that pretty, but with exponents, it might be easier to plug them in. Because notice the question is just like, what is x? It asks for something simple. We've definitely got exponents. I got to know something about a variable and an exponent. What do you notice in the first one? We've got our variables. We've got powers. We saw that before. What else do we have going on? I got a must be. And I've got inequalities relative to 0, interestingly enough. And they say the word negative. So yeah, this is probably going to be a test case. It must be negative. All right, let me test them out. I know that I'm in positives and negatives, so I know I'm in number properties. The one on the bottom, I've got a table. That's weird. I'm going to have to spend some time understanding the table at some point. But any key words jump out of this story problem? Smallest possible value, that's an awesome one. So this is a maximization and minimization problem. I've also got average and median. Right? Average and median jump off the page. So I haven't even started to read, but I'm priming my brain for statistics and max min. And I know I'm going to be working with this table. And look at how beautiful my answer choices are. Smallest possible value, I might just plug them in. Right? Might just plug them in. Cool. We'll do this last but not least. First one, story problem. Ratio or mixture problem. One of the fun things as you start to review is that mixture problems are often weighted averages, which is really just a ratio or proportion type problem. The second one, this is a giveaway for me. Anytime they put this like 100 cents equals $1 or 1 dozen equals 12 eggs, we're going to be doing some sort of conversion. And the conversion is going to be the work. We want to be careful, right? The answer choices are in percents. And notice that they're off by decimal points. 200% times 100 would be 20,000%. And 1,990%, if I multiply that by 100, that would give me 19,900, which means my answer is probably one of those 4. And I need to be careful. Am I supposed to multiply by 100 at the end or not? So I already know a possible trap that I might be facing for this problem. Now notice that in any of this time, I have no idea what to do. I haven't even read the story yet. Don't even know the specifics. I haven't started to jot anything down. But what I'm starting to do is getting my brain just kind of like in the space of that question. First 30 seconds. And what you'll find as you work through these relatively quickly, that first 30 seconds, right, is really powerful. So I'm going to have you try it with just a couple of questions, one at a time, right? I want you to see how much you can get from a question, honestly, even in the first 15 seconds. Yeah. So I'll give you a little countdown for each of these. Did you notice that the answer choices were ratios? Yeah. That we've got a bunch of ratios written out in the problem and repeated words like chemistry, chemistry, biology, biology, statistics. It seems like a lot of interrelated concepts. Okay. Did you try another one? Did you see how spread out the answer choices are? That we're talking about percent, and that we've got like a few up there at the top, a couple way at the bottom. Right? That maybe estimation could be useful. Notice that we've got words like hypotenuse and right triangle, so we know we're in geometry. I've got that root 2 up there, and then I've got answer choices that are clean integers that maybe I could estimate with. They're pretty big. Geometry there, it's obvious, right? They've given me the obvious geometry, and all of the missing information are the angles. I've got answer choices that are way spaced out, but they're not terribly ugly if I want to plug them in. Not terribly ugly if I want to plug them in. Did you notice that we've got inequalities, Roman numeral problem? A lot of them have 2 in it in the answer choices. 2 only, 1 and 2 only, 2 and 3 only. And the language of which of the following must be true. There isn't an all of the above, but there is a none. Ooh, none of the above there. Okay. What do we notice in the first 20 seconds, 30 seconds or so? Variable in the answer choices. We've got 4s, 5s, 125s. And it's a story problem. Plugging in might be a really good method for solving this problem. What about this guy? What do you get from this in the first 20 to 30 seconds? Dollar signs, dead giveaway for a story. I see a person's name, dead giveaway for a story. So pretty, those answer choices. They're so lovely, right? They're close to one another, so I'm probably not going to estimate, but 1, 3, 4, 5, 6, plugging them in sounds like an awesome idea. Nice. All right, so problem solving. Problem solving, things we want to start to look for when we are bumping up against a question and we see what it is. We've taken our breath. We've acknowledged what the type of question is. Now under problem solving, we're going to think about answer choices. So, you know, what type, what quality, what symbols, how spread out are they? Is the problem, and I'll change this a little bit. I think we'll call this story, as I usually do in my head, right? So we're going to call this story problem. Is it math or is it more like geometry? What else do you notice? Are there any content clues, or does it offer up any possible strategies that we could use to solve it, right? Like that might seem like something familiar. And then just note that as you study, you'll be able to have more like content specific strategies at your ready because you'll be practicing them on problems. And so as you're starting to look like, hey, have I seen something like this before? Well, here's the good news. We have something very similar for data sufficiency. And in fact, data sufficiency, we're going to start with the exact same like story, math, geo business, and like, are there any content clues? Same thing, right? The exact same thing that we see in problem solving, we're going to look for in data sufficiency too. But we're going to add a couple of steps, just like we did for problem solving. So we don't have any of the answer choices, right? We don't have all these multiple choice answer choices, but I do have other things I want to go look for, right? And the first of these is, where is it tangled, right? So where is it the messiest? So which parts are the most messy? So we'll look at these three. Where are these the messiest, do you think? Is it in the question stem? Is it in the statements? Is it in both statements? Is it everywhere? For the first one, where is it the messiest? It's kind of all of it, right? I've got some equations in the question. I've got some equations in the statements. It's all kind of balanced. Okay, what about the second one? Where's it messy? Yeah, at least it's tough, but I might say the statements are a little trickier here potentially. The question seems sort of simple. What about the third one? Where's the third one? Oh my goodness, the question stem, right? The question stem is such a mess. What does that mean to me? What I want to notice about where things are messy is that I'm going to have to spend time untangling that early on. So if the thing that's really tangled up is the question stem, I'd better not get all excited and jump into the statement. I'm going to have to give some time to untangle it. Okay, so I want you to do the same for these three. Where is it tangled? And also start to look for like, what are some of the keywords? Is it a story, a mathy, or a geo problem? What are things that jump out at you? Right, so we're gonna start to layer skills. For the first one, there's a conversion, beautiful. What else is going on in the first one? In terms of its messiness, where is it messy? It's kind of like all the same. There's inequalities. I see words like greater than or less than. I also see the word average speed. In the second one, where is it messy? STEM is the mess. I see words like average and revenue. Average and revenue. On the last one, I see a number line. I see the words distance and inequality. It all kind of looks a little messy, but probably more messy in the statements. Probably more messy in the statements. We'll try it again. Take a scan of all three of these on your own. So give yourself, 15, 20 seconds for each one, just to notice what you notice. So the first one's a story. I see the word median. The stem itself is pretty messy, so I'm gonna have to do something with that. The second one, the stem is far and away the messiest. The two statements are relatively simple. It's also a story and uses the word ratio somewhere. The last one is straight up math. We're talking about factors, right? Integer factors. And then the statements and the question stem are kind of messy. So you're starting to get into the same habit. I want you to get into the same habit. I want you to be able to see the first one and be like, ooh, mathy prime, and the statements look just alike. The second one, holy cow, look at the question stem. There's exponents and variables and inequalities, and the statements look pretty simple. The last one, story, ratios, ugly statements. The second one is real ugly. Right? So same idea. I want you to be looking for these kind of qualities of a problem before you're ever trying to solve. Once you've done that, right? So we've got our standards of like, is it story, mathy, or geo? What are some of the content clues? Where is it tangled? We're going to add 2 fun skills. Well, 1 fun skill and then like a little bit of a rehash. So one of the skills is going to be how similar or different are the statements. The more different the statements, the more likely I'm going to have to use different methods to attack them. The more similar, the more reusing of method I can be. Right? Like I'll probably do something similar to both statements. It does not mean that they're both going to be sufficient or neither. It doesn't tell me anything about the answer. Just knowing that they're very similar or very different might just help me see if I can apply the same strategy to each one. And then when I start to think about strategies, the biggest one I'm going to take from my just like big picture visual is like, where am I going to really spend my time getting started? And how much work do I have to do to like rephrase or simplify the question stem? And then as I do a quick scan, if one of the answer choices is like super duper short, I kind of want to like peg that back there so that when I do start working, I might have a statement that I would very happily start with. Right? So if we do the same thing, let me grab one. We'll practice a few. So for something like this one, what about the statements? Similar or very different? Very similar, right? Very similar, very different. Is one of these 2 statements potentially easier than the other on the third one? Yeah, the first statement seems like it's going to be a little bit easier to deal with. Maybe a little bit easier to deal with. Definitely different in all 3 cases. The first one, it's like 2 specific details, but they're pretty different. The second one, they're similar, but statement 2 has less information. It's just x equals 11. The last one, they're both complicated, but they read very differently. Okay, what about these? Similar, different, similar. Right? So in the first pair, we're very similar bits of information. In the second pair, not so much. One's talking about average revenue and then total revenue. But the last one, very similar. We're talking about distance between points. So you're just kind of noticing is one, you know. And then for something like this one, similar, different, one obviously easier than the other. First one, pretty similar. They're both equations. Second one, pretty different. Last one, very different. The second statement seems wildly simpler. Right? So we just want to notice. We just want to notice. Okay, so here's what we're going to do. We are now going to attack a mixed set. Because here's the deal. On test day, they're going to be shuffled up. Problem solving and data sufficiency. Problem solving and data sufficiency. So I've got this a little bit organized such that the stuff that's different is at the top. Right? For all of these, we're thinking about like, is it a story problem? Is it a more mathy type problem? Is it a geo problem? And we're looking for content clues. Right? That's true for both, regardless. What's different though is we'll start to think about maybe some of the strategies that would work. Things like strategies for problem solving would be estimation, plugging in, whereas in strategies for data sufficiency or things to remember is like, which statement do I start with, or where should I spend some time rephrasing up front. For each question though, problem solving, we get to zoom in on the answer choices. Data sufficiency, we're looking at more of a like, where is it messy and how similar are the statements? Where is the problem messy? How similar are the statements? So here we go. We're going to do it. We're going to move through some of these. And I just want you to take, remember, ready, here it comes. Here's your first 30 seconds. Step one, what's the very first thing we do again? When a question hits the screen? What's the very first thing that we do when a question hits the screen? Yeah, we take a deep breath. Right, we take a deep breath. So for each one of these, you're going to take a breath. I'm going to put a little checklist down for you. Take a breath. What's the second thing we do when a question hits the screen? Definitely don't panic. That's what we don't want panic. Panic is no fun. Yeah, we ID the problem type. And then step 3, we're going to go through our little bit of a checklist. Right? As part of that checklist, no matter what type of question it is, there should be this evaluation of story, math, or geo. We should also look for content clues. Alternatively, then, if I'm dealing with problem solving, I am focusing in on the answer choices. And data sufficiency is complexity. Where is it complex? And how similar are the statements? Yeah. You ready? You ready to try this out? Okay. So each time a question hits the screen, your job, take a deep breath. And that's just 20 seconds. Look at how much stuff you guys already have in 20 seconds. Story problem, words like ratio. It is problem solving, and the answer choices all increase by 5. They're pretty nicely spaced out. Okay? And you take a deep breath. In the first 20 to 30 seconds, we've got problem solving problem, variables in the answer choice, words like rate of X houses per week, people painting and doing work. So it seems like it might be a work problem with really complicated answer choices. Really complicated answer choices. Okay, we take a deep breath. Data sufficiency, mathy problem. The statements in the stem are both kind of a little messy. Statement 1 is definitely seems to be like different from statement 2. And I see words like multiple, integer, and an inequality. So maybe some number properties floating around in there. Take a deep breath. Data sufficiency. It's a story. I see the word truck. Right? The statements look almost the same. They just have different like numbers or terms in them, but they're organized in very much the same way. Looks like most of the work is going to be down in the statements. Good news, they're similar. If I can figure out how to assess one, that might help me assess the other. Take a deep breath. Problem solving. Easy answer choices. Look how pretty those are. We've got twice as many. That sounds like some sort of ratio. Nicely done, guys. Nicely done. Take a deep breath. We've got an image, coordinate geometry. Answer choices look like lines. They're all very similar. I see 2s and 3s. So it's just gonna be like moving stuff around. So do I understand how lines work? That might be enough. Right? We'll do one more. Take a deep breath. Nice, guys. Data sufficiency. Statements are similar in that they're both algebra. The stem is a lot messier. I need to know something about ratios or kind of algebra. So here's my advice for you. Let me give you the list of things again, right? For each one. Step 1, we take a deep breath. Right? Step 2, we assess what kind of question it is. And then we have the rest of that first 30 seconds, right? Your deep breath should take you 3 or 4 seconds. Assessing which type of problem it is takes a millisecond. Thinking through what you notice and what possible methods you could use to solve, like you've got the rest of that 30 seconds. What I recommend is grab the official guide. Grab practice tests you've taken before. Grab any any study book you're using. If you're doing any work with like question banks, wherever they come from, flashcards, we've got our flashcards. I want you to practice. So I love this with the official guide. Just open up the official guide to problem solving or data sufficiency and just go through them one after another. Like set a little timer for yourself. What do I notice? I like the little stopwatch timer on my phone because I can start it and then I can just hit the lap button to move to the next question. And I have so much time. I'm not in a hurry. Those first 30 seconds are me just trying to get comfortable with the problem. Because if I'm all like, then I'm probably making some poor decisions. So let the beginning of the problem just be like, look, what do I notice? No big deal, right? No big deal. What do I notice? Nice, guys. Okay, so I had a handful of questions that came in. One of the questions was about number properties in particular, and like what happens if I notice number properties, and how do I go about attacking number properties, right? And so one of the things to think about is like number properties is a huge topic. So one of the things you'll want to start to notice are the words like we saw, right? So we saw words like divisibility or remainder or prime or multiple. When I see those words, I've got a sense that I'm in a divisibility and primes problem. If I see inequalities with a 0 in them, my eyes are going to catch that. I'm probably in a positives and negatives, right? They may say the word even or odd. That's how I'm going to know I'm in an evens and odds. And then when you study, when you start to practice, what you'll do is start to align the way you've solved with problems of that type. So a lot of times number properties are things like testing out cases, plugging in numbers, right? Looking for scenarios. And so if I see this like number properties concept, I'm going to start to think like, all right, this is a little bit more gamey or proofy. If I see distance rate time or work rate time, for me, I know that the fastest way for me to solve those is typically like drawing them out. I'm like, I move this car this far and this far and right? If I see overlapping sets, once I've studied them a little bit, I'll realize that I like to do overlapping sets with tables. Ratios, I like to set up as actual colon ratios. Variables and answer choices, I like to plug in when that's possible. Right? When I'm dealing with data sufficiency questions that are really messy stems, I want to take a breath and give myself plenty of time to deconstruct the question stem and make sure I understand it. So it's getting at that, just like letting myself see pieces, right? Clean answer choices. Maybe I estimate, maybe I plug them in. So the recording for this will be up in YouTube. We'll have this posted on our YouTube channel. Couple of other questions that I had in the background. How often am I looking at my watch for both quant and verbal? I'm not. One, you don't get a watch, but the clock on the screen, I'm not all that commonly. We have a really great technique for putting, 4 questions per page, and we spend about 8 minutes on each one of those questions. So setting like a countdown timer. So we have a really cool technique we do for that in our classes. But essentially what I do is I just kind of tell myself, I have a countdown timer that like counts down multiples of 8 essentially. And I just tell myself every 4 questions, right at the bottom of each of like sort of setting up my book, I want to check in and see, am I a little ahead or a little behind? You also want to start to build like a 1-minute awareness. So if this is my first 30 seconds or 20 seconds, and then the next 30 or so seconds, 40 seconds are actually reading the problem and trying to digest it and aligning it with all these clues that I've seen, if I can get used to doing that whole thing in about a minute, that buys me another little bit of time to like finalize what I want to do, and then a little bit of time to actually do it. That kind of inner metronome, that inner runner's pace, can help keep you on time. Same for verbal, but for verbal, you want to do 9 questions every 16 minutes. So you'll be checking the clock a lot less frequently. Great question in the window, like could a question be both math and story? I think if I called it wordy, yeah. But when I think of a story, I literally just think of something that's like a real world experience. It's got like a person in it, shoes, cars, they're selling stuff, they're buying stuff. The reason why I like to acknowledge if something's a story is that we often think that things need to be translated into algebra. And that's something that kind of gives people a headache, is trying to translate stories into algebra. When the fact that you're a grown-up who lives in a real world often means that you can conceptualize the story without ever having to put it into algebra. That your logic, right, could get you there. And then practice tests. So as part of your normal study, I recommend that you don't take practice tests more than once every 3 weeks or so. The only exception to that is that I do recommend that people take 1 practice exam 1 week out from their official exam, and then 1 practice exam 1 week ahead of that. So you would take 2 practice exams in those last 2 weeks, 1 week out and 2 weeks out. Other than that, you really shouldn't be taking practice exams any more frequently than once every, let's call it 3 weeks. And then I had a question in the window that was asking about like an absolute value where you've got a variable inside an absolute value and a variable outside of the absolute value, or you have like a variable inside the absolute value and a variable in an exponent. I'm going to tell you this right now. If you ever run into problems that you're like, I don't think I know how to solve that, or I think you'd need fancy math to solve that, you're not supposed to use math to solve that. You're going to use some form of like testing cases. You might plug in your answer choices. You might try to find out, well, like when would that be true? Typically in this case, the question would be asking whether X was positive, right? And so you could see like, does this promise me that X is always going to be positive or not? So just things like that. If it seems like, oh my gosh, whatever math I would need to do this is crazy math, you're not supposed to be doing math. You don't get some fancy scientific calculator. You cannot solve for variables that are in bases and exponents, for variables that are inside of absolute values and outside of them. You can't do that without like heavy stuff. Is 3 months enough? And I'll take this as the last question. Is 3 months enough to prepare for the GMAT? The annoying answer, I'm so sorry, is it depends. I think for most people, 3 months is a good amount of time. For our courses are typically 9 weeks, and then we recommend another 6 to 8 weeks after the fact. So ideally, I'd probably peg most people more to like 3 to 4 months to study for the GMAT. If you have less that you need to work on, you can take the shorter end of that. If you have more content that needs to be reviewed, and you have some, like you haven't really touched the strategy before, you haven't done any studying, you might need longer for that. So the biggest thing I would say to anybody who's at the beginning of their studies is take a practice exam and then review it. And as you review it, you'll look, did I understand the question types? Yes or no? If I don't understand the question types, I got to do some work there. Do I need work on both quant and verbal? That might mean that you have to spend more time. Or is your quant already a score above a 45 and you just need to work on your verbal? Or is your verbal score over a 40 and you just really need to focus on your quant, right? So it'll just depend. I've had some students who are able to study in 2 to 3 months. I've had some students need more like 4 to 5. It's usually those first couple practice exams that'll let us know. Oh, and then the last question I had, I'm so sorry, was what's the difference between a one-on-one session and private tutoring? Nothing. With our company, private tutoring is like a one-on-one. We do offer for folks that take our Interact or our courses, we do offer a thing called coaching, which are also one-on-one sessions. But those are a little bit different. They're structured more to help you plan how to study as opposed to being more like official tutoring. And then the week before the exam, I recommend that people do very little, very, very little. I don't review much in depth. I don't do any new information the 2 weeks before the exam. In the week of the exam, I might do a little bit of like practice. I'll do some practice problems, particularly going back over problems I've already done. I really like to redo old problems that week. I like to limit my work to no more than an hour or so. And then the 2 to 3 days before the exam, I try to do almost nothing. You can just kind of forget that the GMAT exists. There's nothing on the test that is anything that you would need to work on the day before. Right? Like you won't forget any of it. This is not a test of regurgitation. And unfortunately, no insight as to whether they're going to extend the online test beyond June 15th. I have no idea. I have no idea. I wish we knew. I wish we did know, but we don't know. They do say on their website that they will keep monitoring the situation. But all right, I will stick around for another couple of minutes. But guys, thank you so much. It has been a pleasure. Happy Monday. Happy free GMAT prep hour. Happy studying. Good luck. Don't forget, take a breath. I think that just helps no matter what, right? Even if you're not doing questions. All right, thanks, guys. Have a good night. Have a good night.